Step 1. Framing the problem as a 0/1 knapsack. In our case, each song is treated as an item in the knapsack. First, the duration of the song is its weight. Second, the endorphin level, give its value. Third, the total listening time or allowed, let's call it S, becomes our knapsack capacity. So our goal is to pick songs that maximize our total endorphins without exceeding the total time. Step 2. Calculate the total set of songs. Here, we deal with a fixed set of songs. First, we add up the total duration of all 10 songs, which we call total underscore song underscore time. Then we calculate total underscore endorphins underscore per underscore set. That's the sum of endorphins for all 10 songs. Now we ask how many full set of 10 songs can fit into our total time S. We compute it using full underscore set equals to S divided by total underscore song underscore time. Then we find the remaining time. Remaining time equals S modulo total underscore song underscore time. From the full set alone, we already gained some happiness. Base underscore endorphins equals full underscore set multiply by total underscore endorphins underscore per underscore sets.
Step number 3. Now that we have our remaining time, let's use dynamic programming to find the best possible combinations of songs that fit into it. We'll create an array called dp where dpt represents the maximum endorphins we can gain using exactly t seconds. This array should have a size of remaining underscore time plus 1 and we initialize all values to 0. Then we iterate through each song and for each valid time slot, t minus from remaining time down to the song's duration, and then we update dpt. The formula looks like this. dpt equals max, open parenthesis, dpt, and dpt minus duration plus endorphins, close parenthesis. This ensures we don't pick the same song more than once in the same iteration, which preserves the 0-1 knapsack constraint. Next, step 4. If we want to track exactly which songs we picked in the partial selection, we can maintain a parallel array called chosen. Chosen T stores the list of songs and used to reach that dpt value. Whenever we update dpt, we also update chosen T like this. Chosen T equals chosen T minus duration plus song number. By the end of the loop, chosen remaining underscore time gives us the list of song numbers selected for that partial time. Last step, step 5. Now that we have both our base and partial results, it's time to combine everything. Total endorphin is simply base endorphins plus dp remaining underscore time. Final song list choice is made of two parts, the full sets of all 10 songs and the songs from chosen remaining underscore time. And that's it. We found the most optimal list of songs to maximize endorphins within any listening time.
So, good day everyone, I am SENBIE. So, let's come now to the explanation of our code. So, in this code, we calculate the maximum endorphins one can achieve from listening to a set of songs within given durations. It utilizes a dynamic programming approach to optimize song selection. So, for the code overview, let's come now to song data structure, which is the code 1 or the image 1, where the list songs contains tuples where each tuple represents a song by its length or in seconds and its corresponding endorphin level. Example, we have here the example entries, which is the 500 to 500. Represents a song of 500 seconds that provides 500 endorphins. So for the second one, which is the dynamic programming function, which the function name max underscore endorphins with the S as its durations, inputs S total listening time in seconds, and for the process, it's calculate total time and endorphin contribution of songs. It's also determine how many full sets of songs fit within the duration. We also use dynamic programming to optimize the selection of additional songs within the remaining time. For the output, it returns the maximum endorphins possible along with the chosen songs for that duration. So, for the next code, we also have the output generation, where it has the loop through durations and output formatting. For loop through durations, it iterates over various predefined durations, which is the duration list. For output formatting, it generates a display string for for full sets of songs and partial picks if time is left after filling with full sets. It also has its conditions, which is its different outputs based on the number of full sets and available partial selections. For the initialization of the code, we have the duration definitions, header printing, and header printing is the header field. So let's come to duration definitions. Durations is an array of possible listening times, while header printing, it prints a formatted table header to outline the result for each duration. For the header fields, it has listening duration, choice of songs, and total interframes. So, for the execution flow, we have the initialization. It's defined song list with their lengths and endorphin values. And it also set listening durations to test. Second is the dynamic programming calculation. It calculates the maximum possible endorphins for each duration using the max underscore endorphins function. For the output generation, it formats and print results based on completed sets and remaining songs. So this program provides a comprehensive analysis of song selections to maximize endorphins based on varying listening duration, utilizing a dynamic programming approach for optimization.